A ship goes dark in a contested sea. Its public tracking signal disappears. There is no distress call, no clear image, no confirmation. But above the clouds, a radar satellite catches a shape. A radio frequency sensor detects an emission. A database remembers the ship's past routes. An AI system compares the fragments and raises a question, not "where is the ship?" but "what changed?" The AI watching the planet is not one machine. It is an architecture, satellites, sensors, cloud systems, military networks, and algorithms trying to turn Earth itself into searchable intelligence. That is the new frontier of satellite intelligence. Not just seeing Earth, but searching it. For decades, military advantage came from seeing what others could not. Today, the harder problem is different. The world already produces more information than humans can read, watch, label, or understand. Satellite images, drone video, radar returns, ship transponders, aircraft signals, weather data, battlefield reports, commercial imagery, classified feeds. The bottleneck is no longer collection. The bottleneck is comprehension. Inside this system sits a familiar human role, the defense analyst, not someone watching the entire world on one perfect screen. An analyst usually faces a narrower question. Has construction changed near this border? Did a missile site become active? Why did ships leave port at night? Is a convoy real or a decoy? The pressure is not just to see, it is to decide what seeing means. During the Cold War, reconnaissance was scarce. U-2 aircraft, SR-71 flights, and early satellites delivered information that was rare, expensive, and slow. Then came persistent surveillance. After September 11th, drones and full-motion video created the opposite problem. Instead of too little imagery, there were too many feeds, too many hours, too many screens, too many events buried in ordinary movement. Project Maven, launched by the U.S. Department of Defense in 2017, became one of the clearest inflection points. Its goal was to use AI to help identify objects in drone footage, while exposing the ethical tension around commercial AI techniques in defense workflows. That tension never went away. The same methods that recognize cars, roads, buildings, and objects in civilian datasets can also become part of military intelligence. Now imagine Earth as a layered map, not made of borders, but of signals. One layer is optical satellite imagery, recognizable pictures of ports, bases, runways, roads, bridges, and cities. Another layer is synthetic aperture radar, or SAR, which can image through clouds, smoke, and darkness. Another layer is radio frequency sensing, invisible emissions from radars, ships, communications equipment, and electronic systems. Another layer is open source intelligence, public videos, shipping records, aircraft tracking, news footage, commercial databases, and official statements. Alone, each layer is incomplete. Together, they become more powerful. A satellite image may show a vessel. AIS data may claim an identity. Radio frequency detection may suggest hidden activity. Weather data may explain why optical imagery failed. A public video from a harbor may confirm timing. The central mechanism is fusion. AI does not magically know the truth. It compares weak signals, detects patterns, ranks possibilities, and points humans toward what deserves attention. This is the real shift. Defense intelligence is moving from watching individual feeds to querying a living patchwork of the planet. The phrase digital twin of Earth is often used, but it can mislead. No country has a perfect, real-time, high-resolution copy of the entire planet. The real system is uneven. Some areas are monitored frequently, others only occasionally. Some data is minutes old, some is days old, some is missing, some is wrong. What is emerging is not omniscience. It is competitive awareness, a system that makes more of the planet searchable, more often, especially where strategic decisions depend on small changes. The most important AI tool may be change detection. A human can compare two satellite images, but when the number of images becomes enormous, AI can search for differences faster than human teams can. A new aircraft appears on a runway. Tire tracks lead to a hidden site. A radar battery moves. Construction begins near a border. Ships leave port at an unusual hour. Most changes mean nothing. Some changes matter. The algorithm does not need to understand geopolitics the way a human does. It needs to surface the small fraction of images that deserve attention. It says, "This changed," or more carefully, "This deserves human attention." In Ukraine, this kind of visibility has changed how war is observed. Commercial satellite imagery, drone footage, public maps, and military intelligence all became part of a wider information environment. Convoys, damage, defensive positions, and infrastructure strikes could be compared far beyond classified rooms. This does not mean war is automated. Artillery still fires, soldiers still move, civilians still suffer. Political decisions still matter. But Ukraine showed that war is harder to hide when commercial eyes, public data, and machine machine analysis are all watching. That visibility creates new power. It also creates new risk. A model produces a confidence score. The analyst has to ask, what was the model trained on? What is missing from the data? Is the pattern real? Is the adversary spoofing the signal? Could civilian traffic look like military movement? The same tools can serve non-military missions. After hurricanes, fires, floods, or earthquakes, satellite AI can help identify blocked roads, damaged bridges, flooded neighborhoods, or areas needing rescue. This is why the technology is not simply good or bad. It is dual use by design. Commercial companies such as Planet, Maxar, BlackSky, Capella Space, ICY, Umbra, and Hawkeye 360 provide pieces of the sensing layer: optical imagery, radar, analytics, and signals intelligence. The result is a new kind of infrastructure, not just satellites, a market for seeing what changed and turning planetary data into decisions. For defense organizations, this creates a difficult integration problem, connecting sensors, commanders, platforms, and analysts without drowning them in noise. That means cloud systems, data standards, secure networks, model validation, human review, rules for what can be trusted, shared, or acted upon. Military systems were not built as one seamless organism. Older platforms, classified databases, commercial feeds, allied networks, and battlefield units often speak different technical languages. AI can help fuse the picture, but the network carrying that visibility can still break. Clouds block optical satellites, smoke obscures fires, cities confuse algorithms, decoys mislead models. Signals can be spoofed, satellites pass overhead, then move on. A brilliant image may arrive too late, a confident alert may be wrong. This creates the black box problem. If a system flags a target, ranks a risk, or recommends an action, people need to understand why. Not perfectly, but enough to challenge it. Enough to know when the machine may be confident for the wrong reason. That is not just a technical requirement, it is a command requirement. The stakes are geopolitical. If one country believes another is preparing an attack because an AI system detected movement, the question is whether the interpretation is correct, whether leaders trust it, and whether there is time to verify. Visibility changes the game. It does not end uncertainty. The most dangerous line is the sensor-to-shooter loop. Detection becomes classification. Classification becomes recommendation. Recommendation becomes targeting. Targeting becomes engagement. Many militaries say humans will remain in the loop, or at least on the loop. But in a crisis, speed becomes seductive. When detection and decision systems accelerate, institutions may feel pressure to trust alerts faster than uncertainty can be examined. Automation bias is not the disappearance of humans. It is the quiet transformation of human judgment into approval of a machine-shaped conclusion. That is why the analyst matters. At the end of the chain, someone still has to ask whether the pattern is real, whether the context is understood, whether the evidence is sufficient, and whether the action is lawful, necessary, and wise. The AI watching the planet is not an all-seeing eye. It is a contested intelligence architecture, part satellite network, part commercial market, part cloud platform, part battlefield operating system, and part geopolitical weapon. Its rise will not end the fog of war. It will transform the fog into data, probabilities, alerts, gaps, and contested interpretations. So the final question is not whether machines will see more than humans. They already do. The question is whether human institutions can remain responsible for what machine vision makes possible. Imagine a future crisis where an AI system detects activity that looks like preparation for attack. The confidence score is high, but not certain. The evidence is fast, but incomplete. Waiting carries risk. Acting carries risk. At that moment, the most advanced technology on Earth may not be the satellite, the model, or the network. It may be the human capacity to pause long enough to know the difference between seeing something and understanding it. If you enjoy deep dives into the technologies shaping our future, consider subscribing to HiTechnomy. This is HiTechnomy. Look beneath the surface of the future. Join us next time as we explore another technology, system, or breakthrough shaping our world. Powered by Alligence Labs.